Okay, kiddos, now let's talk about the last part of Unit 5. So we're going to talk about proving triangle congruent. So we talked about how we can prove that a triangle is congruent last time. We remember congruence means same size and same shape, right? And we said to be the same size and the same shape, we said when we're given congruent polygons, right? If we know that they're congruent, that we know that corresponding sides are congruent and corresponding angles are congruent, right? So we're going to say that those are both parts, right? Sides are parts and angles are parts. So we're going to remember CP, CTC. Okay, what that means is congruent parts of congruent triangles are congruent. Okay, so if we think about that, that makes sense. The congruent parts of congruent triangles are congruent, right? So if they're one part would be their sides, right? If those are congruent on one, they're congruent on the other. Another part would be the angles, right? If those are congruent on one, they're congruent on the other. Okay, so what we're going to talk about today is how we can do what we call a proof. So a proof is right over here. So this is a written explanation of how we can prove this. So let's look at this. It says given side BC is congruent with side DA. So BC and DA. Okay, so we see that they're both congruent because we have this symbol right over here, right? That tells us that this side is congruent with this side. So BC is congruent with DA. We remember the given statement, whatever they give us is always first. So this is first is always given. Okay, so the first one's always given. All right. Now, what is this? What is that talking about? What kind of parts? Are those angles or sides? These are sides. So let's write side over there. S for side, right? Okay, next. BC is parallel with AD, right? This means parallel. Okay, so if we look over here, BC is parallel with AD because of this symbol, right? That tells us it's parallel. Well, how do we know that? Well, that was also given, so that's why we wrote given there. Okay, next. If this is equal to this, right, and that's parallel to that, then we also know that angle BCA, okay, this one, BCA, is congruent with DAC, DAC. Okay, how do we know that? Well, we talked about when we have parallel lines cut by a transversal, right? So if this was cutting it like this, right, and we have these parallel lines this way and this way, right, then we know that the angles created right over here and right over here are congruent. Okay, so, and we know that because of the alternate interior angles theorem. So if you remember, we talked about that in recent lessons. So what does that represent? If this is congruent with that, those are angles, right? Angles. These are sides. So that's going to be an angle right there. Right? Next, AC is congruent with CA. AC is congruent with CA. Okay, so if we think about it, these are two triangles, right? Just like that and like that. Okay, these are the triangles that this is. This is one triangle right here, right? This is another triangle right here. They share this same side, right? That's the same side on both of them right over there, right? And we know that because of the reflexive property. We talked about that in recent weeks. Reflexive is like a mirror, right? Reflects like a mirror. So if we go one way, that's the same as the other way. So what does that represent? That also represents a side, right? So if we go from side, angle, side, then the reason how we can prove that triangle ABC is congruent with triangle CDA is because side, angle, side, right? Just like we practiced last time, side, angle, side. Okay, so that's the basics of what we're going to do today is we need to prove by using mathematical reasoning why it's congruent. Okay, by using what we practiced last time. So we're just building on what we've been doing. All right, so let's look at how we're going to do that. This is a cheat sheet, little cheat sheet of how we can prove triangles. Okay, so let's look at this first one right over here. Okay, what if I told you that A is the midpoint of EB? Okay, so A, that's saying point A, is the midpoint of EB. This one right over here, EB. Okay, well, if that's the midpoint, right, middle means the two sides are equal, right? So that means that is congruent with that. So that is the definition of a midpoint, right? If we have a middle, that means it results in two segments being congruent. Okay, so that's hidden information. If I tell you it's a midpoint, the hidden information is that the two segments are congruent. So that's the hidden info. Okay? All right. So if that's the case, then what is congruent with what? We would say BA is congruent with AE, right? Segment BA is congruent with AE. All right? Next, let's think about this one right over here. Okay, what if I told you that AD bisects angle BAR, line AD, so this one right here, bisects BAR. Okay, so bisects means cuts into two equal parts, right? So if it's going to cut an angle, it cuts this angle into two equal angles, right? So that means angle BAD is congruent with angle DAR, right? DAR. And that's because that's the definition of an angle bisector, right? Bisector means it cuts into two equal parts. If this line cuts this angle, then that's an angle bisector. Okay, next. If I told you that two angles are vertical, then we know that they're congruent, right? So if I told you that this line right here and this line cross, right, then we know that this angle and this angle are congruent, right? So that would mean this angle right over here, BAC, angle BAC, is congruent with DAE, right? DAE. And that's because of the vertical angles theorem. Okay? So those are the first three hidden information, right? If we know it's a midpoint, then we know that those are equal, right? If we say this bisects, then we know two angles are congruent, right? If we know it's vertical, then we know those are two are congruent, right? That's the hidden info, right? Hidden info, hidden info. And that's what we want to understand by knowing that. Okay, next, reflexive property. We said the reflexive, when two angles have triangles have a side or angle in common. So if we look over here, these two triangles share that, right? So if we imagine, right, like one triangle is like that, A, B, D, right? And then the other triangle is like that, still that same A, still that same D, but this one's C, right? So this one shares this same side AD right over there. Okay, so that's called the reflexive property. Okay, then this says perpendicular lines form right triangles. So this means perpendicular, right? Okay, so perpendicular lines are ones like this, right? We know that they cross and form a right angle. Okay, so if we told you AB is perpendicular with CD, AB is perpendicular with CD, that means it makes two right angles, right? This one and this one, right? So the first angle would be ABC, and ABD ABD are, they're both right angles, right? If these are perpendicular, then we know that those are right angles. That's the hidden info. Okay, hidden info. And that's the definition of perpendicular lines. Perpendicular lines cross at a right angle. All right, then our final piece of hidden information. The definition of parallel lines. If AB is parallel to DC, okay, AB is parallel to DC. We're going to mark that, right, by that little arrow, remember? Okay. If that's true, then we remember that if we have parallel lines cut by that transversal, then this angle right here is going to be equal to that angle right there, right? So that means this angle BAC is congruent with this angle ACD, right? ACD. And that's the definition of parallel lines cut by a transversal. Okay, so let's keep this information in mind as we practice on our next page. Okay, so those are the reasons that we're going to use for this next upcoming part. Okay, so now here's what we're going to do. Let's look on this is the back side of the paper. What we're going to do is we're going to use these reasons. Definition of a midpoint, definition of angle bisector, vertical angles theorem, reflexive property, definition of the perpendicular lines, and definition of parallel lines. Okay, we're going to use those as reasons to say how we can prove these items. All right, so let's take a look at this first one on our we do. This says given AC is perpendicular with BD. Okay. Okay, this says AC is perpendicular to, right? Perpendicular to. Okay, so if AC is perpendicular to BD, complete the flow chart below. Okay, so let's look at this. Okay. That's the first part. If AC is perpendicular to BD, that's because it's given, right? Then we also know this, right? I'm going to go ahead and give you this one, okay? We know that ADB and CDB are right angles. How do we know ADB, and CDB? How do we know these are right angles? Well, because perpendicular lines form right angles. We just talked about that on this other page, right? If these are perpendicular to each other, right? That's what it's saying. These are perpendicular. That means these form right triangles, right angles. All right. Next, let's go and figure out the other part of this. Okay, so next, this says ADB is congruent with CDB. ADB and CDB. So how do we know that ADB and CDB are congruent? Well, if we look at our options, let's go ahead and click over here on the options. The options come up to all right angles are congruent. That's why. All right angles are congruent. Okay, what about this one? AD is congruent with CD. AD is congruent with CD. How do we know that? Well, if we look over here, we see that, right? And the reason why is because they give it to us, right? It's given to us by these marks right here, right? It's given to us by these marks. All right, next, how do we know that AC is congruent? I'm sorry, angle A is congruent with angle C. Angle A is congruent with angle C. Well, they gave it to us also, right? That's given. Right? It tells us that those are congruent because those each have one arc, right? One arc, one arc. So that answer also is given. Okay? And then our last one. Well, then how can we prove that triangle ABD is congruent with CBD? Right? How can we prove that both of these are congruent to each other? Well, let's go through these. What is this? This is an angle, right? Okay, what is this? This is a side, right? Okay, what is this? This is a angle. Okay, so the reason is ASA. Okay, so those are our answers. Given. All right angles are congruent. ASA and perpendicular lines form right angles. Okay, so that's what we're doing. We're just using that information. Let's go to the next one. It says, given that D is the midpoint of AC. D is the midpoint of AC. Okay, well, if it's the midpoint of AC, what's the hidden information? Well, the hidden information is that in that, right? That's hidden. Okay. Why is it hidden? Okay. Well, if we know that um, D is the midpoint of AC, because that's given to us, right? They tell us right over here. Okay. We know that AD is congruent with CD. AD is congruent with CD because that's the midpoint. Let's change that color. That's the midpoint divides segments into two congruent segments, right? That's what we talked about. Okay? The midpoint, as we said, that's the midpoint. It's going to divide this into two equal parts. That was the hidden information. Okay, what about, and that's a, let's look at this. Angle A is congruent with angle C. Angle A is congruent with angle C. How do we know that? Well, that's given to us, right? Given to us. So that's the reason on this one. How do we know that AB is congruent with CB? AB, CB. How do we know those are congruent? Well, that's also given to us, right? That was given to us, so that's the reasoning. So we're just writing down how we came up with these conclusions. Then, how do we know that these triangles are congruent? How do we know this is congruent with this? Well, this tells us a side, right? This tells us an angle. This tells us a side, right? So we're going to say that one is side, angle, side. Okay, next, let's keep it moving. Given that BD bisects ABC, angle ABC, BD, okay, bisects ABC. So ABC. Okay, well, if it bisects that angle, that means it makes into two separate angles, right? So that means ABD is congruent with CBD. Why are they congruent? Because an angle bisector divides an angle into two congruent angles. Right? That's what an angle bisector does, right? We say bisector makes two congruent parts, two equal parts. All right, next. AB is congruent with CB. AB is congruent with CB. How do we know that? What's the reasoning for that? Well, the reasoning is because it's given to us, right? That's the reason it is. All right, what about this? BD is congruent with BD. BD is congruent with BD. That means that is the reflexive, right? Reflexive. Okay, so how do we know that these are congruent then? What was our information? This is a angle, right? This is a side, right? This is a side. Okay, so let's go in order. We have to go from this is a side, angle, side. So it's not ASS or SSA, it's side, angle, side. side, angle, side is our reason. All right, so I know you have this. If you have any questions, just let me know. Just do our practice, and then we have our test next time.